Hey students, in this video I'm going to use some practice problems to continue what I explained in the previous video of attributes of quadratic functions. So in this assignment in class, I gave an option where you can choose whether to do the worksheet of problems or create an anchor chart for you to show that you understand the attributes. If you are doing the anchor chart in class, please choose one of the following quadratic functions listed below. Just pick one of those. And then I need you to either graph it in an anchor chart paper or a piece of paper, a color paper. And I want you to make sure you accurately describe how to find all these. Either color coordinate them, label them correctly, just pretty much show everything in details for others to understand how to find these attributes on the function that you're doing. This is an example of the anchor chart that I have from last year in case you want to see it. So if you are taking that route, go ahead and do that. But if you're doing the worksheet with me, then I'm just going to go over problem number 1, and you will just show mastery and understanding by completing the others. Okay, so the vertex on this first problem, it's that turning point up here of this parabola. So the parabola, it's going to be -3 and +2 as a maximum value on the vertex. And then it's a maximum. So that's the highest that it goes. And then it's going to go down forever. So with all this information, just by looking at it, we can fill in -3, 2, the maximum of y equals 2. And then we know that it has arrows pointing down forever and also going at an angle, left and right. So we can say all real numbers for domain, because it's going left and right forever. And then we can also write it as -infinity, +infinity, with parentheses aside. For the range, it's going up and down. Maximum, we said the maximum was 2. That's the highest that this graph goes. And then infinity below that, -infinity below that. So we can say that the range is any y value that is less than or equal to 2. Or we can also write an interval notation saying that the minimum is -infinity, the maximum is that 2, and parentheses for -infinity and bracket for +2. So the other attributes, the axis of symmetry, we talked about showing that with a invisible line that cuts through the middle where that vertex is at. And it's just pretty much saying where that line is going to be. So we're going to say that the axis of symmetry is when x equals -3. And as I mentioned before, these two, the axis of symmetry and the minimum or maximum value put together create your vertex. So just keep that in mind as you proceed with the next problem. As far as the word 0, 0 means also x-intercepts. And then it also means solutions. So whenever you see these other questions being asked on the other examples, so like right here, it's asking for solutions. The other one's asking for roots. So that's another word for this as well. These all represent the same thing. They all are found in the same area right here where it touches the x-axis. So we're going to say that the zeros here are -4 and -2. You can write them as values or you can write them as points. And that's it. That's how you identify the attributes for all the details in this graph. I hope this video helps.